So in this case, we have got question number 7 that we are going to consider from our April 2026 exam based on our metal cutting machines. Question number 7, 7.1, a round shaft of 70 millimeters in diameter is machined on a length. So it's machined on a length. So this one we are dealing with what? A center length. So based on the introduction, go through the playlist. You're going to see that we have got now the introductions that you can use to recap that those calculations, and you can see that it is similar, much similar to what we had before. All right, they gave us the diameter. This is part of what? Of the shaft. All right, so you're given the diameter of the shaft. All right, which is in meters divided by 1000, that's 0.07 meters. You can obtain the radius from there. Then the cutting force applied on the cutting tool which is on that shaft. So that cutting force is the shaft force. So since it's applied on the what? On the shaft, that's your shaft force, 2000 Newton. Assuming 12 Newton meter of torque is lost due to friction in the bearings of the spindle. So this is the torque that is lost due to friction. I'm just going to write as T friction in this case. All right. So calculate the following: 7.11, the torque that is required at the driving pulley of the length. All right. We worked with this one as an example, if you still remember. So that was simply going to be the driving pulley. So from this here, we have got the pulley here. So the radius from force, you can have the torque. As we understand, torque is what? Force times radius from our formulas. So from the pulley, if it is from the pulley, this must be from the pulley, from the pulley, from the pulley. That is the consideration. So we can calculate the torque of what? Of the pulley that you're given there. If you can obtain what? If you can use that force of what? Of the driving pulley. So we do not have the force of the pulley. All right. So here, what we can use is to take this one of the friction. Since we've got the torque of the friction, we can use that one. All right. So here we can use that one of the friction, 12 Newton meter that we are given there. All right. So here, what we can do is to find from the shaft, we can find the torque of what? Of the shaft. Add these two, they give us that one of the pulley. All right, so we're limited with this formula. This one is limited for now. Yes, we're going to use it maybe here on that one, but for now it is limited. So here you can add that of what? The shaft plus that one of what? The friction is like the total friction of the pulley. So from the shaft, you have to calculate it from what? Force times what? Force times radius. So T shaft here is from the force of the shaft, all right, times what? Times the radius, just like here, pulley, force times radius. So here you use the radius of what? Of the shaft. So the force of the shaft is what? 2000, which is your cutting force, times the radius, divide by 2, 0.07, divide by 2 in meters. That was going to give us the torque of what? Of the shaft in Newton meters. So that's 70 Newton meters that you're going to have. So adding those two, the shaft and the friction, the shaft 70 and the friction 12 was going to give us 782. All right, sorry for that. This is 82 Newton meters. So that's the torque of what? Of the pulley, the driving pulley. All right. Then 7.12, the driving force required at the driving pulley of the length if it has an effective diameter of, so we are given the diameter this time at the driving what? at the driving pulley. Remember, here we talked about the pulley here. So we can use that formula to calculate the force because we now have what? The torque of the pulley. The radius of the pulley can be determined from what? From the diameter here of what? Of the pulley. So since we've got this diameter of the pulley divided by 1000, that's 0.3 meters. The radius of the pulley, therefore, was going to be divided by 0.15 meters. So you can have what? The driving force required at the driving pulley. You are still working with the pulley. So this is from this formula. We can have it as the subject, all right? So that's 7.12. The force of the pulley is simply going to be divided by the radius of the pulley here. So that's the torque of what? Of the pulley divided by the radius of the pulley, just like that. So this is it. With this information, you are done. Simply divide. You have it 82 divide by the radius of the pulley here 0.15. So that was going to give us the force of the pulley in this case, which is what? 546,667 Newton. So that's the force of the pulley from what we have. All right, direct as it is, the power required at the driving pulley. So we need the power required at the what? Driving pulley of the lathe if it rotates at this speed. So we are given the speed. All right. So what can we do? The power at the driving pulley is the output power, remember. So this is our output what? Output power. So output power can be determined from since it is the driving pulley. So remember power, we've got the torque of the pulley here. Power is equal to 2 pi nt over 60. So from the speed, use the torque of what? Of the pulley there. So it's going to be 2 pi n, the torque of what? Of the pulley. Since we're dealing with what? The driving pulley, the torque has to be taken from what? The pulley over 60. So that's our output power. 2 pi times the speed, 300 revs per minute that we are given there. So that's it. Times the torque of the pulley. We calculated that 82 over 60. So that's simply how you can play around with these typical questions, all right? You simply need to play around with such typical questions, understand what you are given. So that's it, all right? So that was going to give us the output power of 2,576,106 watts. This is power measured in what? In watts, like that. So that's your 7.1.3. Then 7.1.4, the power that must be used, that must be supplied to the electric motor. The power affecting the motor is what? The input power. If you are given 80% what? Efficiency. There is efficiency. So what can we do? We can take advantage of what? The output power. Since we have that output power, so we can use efficiency. Since efficiency is output over input. The output, we have it. This is what we need, the input. So the input is going to be output over what? Over efficiency. So output 2576,106 over efficiency as a decimal. Since I did not use 100% here, I'm going to use efficiency as a what? As a decimal, 0.8 divided by 100. So that's what? 0.8. So that's the input power. The power affecting the motor is what? Your input power, the motor. So that's 3,220,133 watts, like that. So this is what you're going to get from this information. All right, 7.2, moving to this part, it is now dealing with a grinding wheel. So that's from the surface grinding machine. All right, we are given the diameter. All right, our diameter in millimeters divide by 1,000, 0.11 meters. Rotates at this speed. The speed is what? 2,500 revs per minute and exerts a tangential force. We are given the tangential force 35 Newton on a workpiece. So the tangential force is on the workpiece. Then the motor driving the grinding wheel rotates it. So this is the speed of the motor. This one, the speed of the motor is given, and this is the efficiency. All right. So calculate 7.21, the output power at the grinding wheel. So here, since we have diameter and what speed, we can have the velocity so that we can calculate power from what? The tangential force. Remember velocity, pi dn over 60. So that's V is pi times d, 0.11, all right, times 2,500 over what? Over 60. That's what's going to give us the value of V, 14,399 meters per second. So that is our velocity from here, the tangential what? The tangential velocity. Why looking into this tangential velocity? Because we have the tangential what? Because we've got the tangential force. So we can simply work with what? That tangential velocity and the force to determine what? The output power as the output power is equal to what? Force times velocity. So the force is the tangential force. You multiply to the velocity in what? Meters per second. That's it. Your tangential force, 35. Your velocity, 14,399. That was going to give us the output power from the information that we are given of 500. So it was going to be 503,965 watts as the what? Output power. So 7.2.2, the input power of the motor. So remember, the motor, it is exactly the one, the input. So we can simply use what? Efficiency. Since we are given that efficiency, 7.22, you can use what? Efficiency as it is power output over power input as a decimal 0.6. So we need input, make it the subject, cross multiply, then divide by efficiency. So input is going to be output over what? Efficiency, just like that. Using that efficiency and output, 503,965 divide to the efficiency of what? 0.6. That was going to give us what? The input power of the motor. That is 839,942 watts, just like that. So do revise as many questions as you can as you are preparing yourselves for the exams ahead of time. You need to work out as much questions, right? Where you do not understand, let us communicate through our comment section and as well our community section. So for now, that is it. Till we meet again.